Dear learners, I welcome to the course Environmental Issues. In this session, we will be discussing about anthropogenic causes of climate change. In the last session, we have seen about the natural causes of climate change, how important the issue of climate change is, and we have discussed in detail each and every causes, particularly the solar variability, orbital variations or Milankovitch oscillations, the tectonic processes, and also the volcanic eruptions. These natural causes have been there in the past, in the geological past, and they have caused a lot of changes in the Earth's climatic condition. However, the Earth's climate, if you look at it, it has been changing in a very narrow range. And this change is quite common in the Earth's history, if you look at it. But the present day climate change, if you look at it, it is basically a different one for the reason that it is very rapid. And the second important reason is that the present day of modern climate change is because of human action. This modern climate change, if you look at it, it has to be addressed sincerely with all efforts possible. Because this modern day climate change is going to affect us in every way. It is going to affect all the living organisms, and that is the reason why the climate change, global climate change is significant. And this has led to the mass extinction. Perhaps we are in the 6th wave of mass extinction. It is going to affect every ecosystem as much as possible, because the changing climatic condition is going to affect the ocean system, terrestrial ecosystems, aquatic ecosystems, land masses, all the living organisms for that matter. And this is a significant factor because the rapidity of change, it is increasing year after year, and the impact can be irreversible at times. So for that reason, we need to understand the causes of climate change. As I said, that there are natural causes of climate change is there, but their contribution to climate change is very meager, and it also is having a longer time frame. But in the present context, if you look at it, the human actions are very, very important thing. So let us see the anthropogenic causes of climate change. The human influence on the climate system is very clear. It's definitely unequivocal. And the recent anthropogenic emissions of greenhouse gases are perhaps the highest in the history. The recent climate changes have had widespread impacts on both the human and also the natural systems. It is essential to attribute the changes in climate to either the natural causes or human influence. This attribution of the climate change to either these factors is very, very important thing. So then only we can understand the probable mitigation strategies. However, it is a great challenge to attribute the causes of climate change because the climate system is highly complex. Further, the natural causes of climate change prevail over a longer period of time, and the natural causes are overlaid by the human-induced causes. So again, it's a complex phenomenon to attribute the cause of climate change. However, we need to take the steps possible to find out exact reasons what is making the change in the climatic condition. As I said, that the drivers of climate change can be both natural and anthropogenic activities. In the industrial era, since the industrial revolution, if you look at it, the human activities are more responsible for causing climate change. The anthropogenic drivers are basically the economic activities or use of fossil fuels that has led to the changes in the greenhouse gas concentration in the atmosphere, and also changes in the land use changes. Land use, that is also a significant factor. The third one is the changes in the aerosol concentration. So let us discuss each and every cause, anthropogenically induced cause, one by one. These changes are responsible for changing the climate system as well. As I said, that the increase in the greenhouse gas concentration can have an important role as far as the dynamics, whether it's atmospheric composition or even the carbon dynamics or nitrogen cycle. So this greenhouse gas concentration has to be taken very importantly, significant, because it is having a significant contribution to every aspect of the human system and also the natural system. So the atmospheric composition, let us look at the atmospheric composition. What is there? What has changed since the Industrial Revolution? When you look at the atmospheric composition, it is mainly made of nitrogen, oxygen and argon. It's a huge amount, but very meager amount, that is even less than 1%, has been made of by this trace gases, carbon dioxide, the water vapor, the nitrous oxide, methane. These are very meager amount, but these are playing a very important role in the climate system because they are going to cause warming of the Earth's surface temperature. These are called as radiatively active gases. Very important gas as far as radiatively active gases is water vapor, because these are naturally available in the atmosphere and their role in warming the Earth's climate is well documented. In the post-industrialization, the increase in the other greenhouse gases are very, very important. That is, they are basically due to the human activities. The extent to which each greenhouse gas perturbs the climate system over a particular time period depends on the concentration of the gas in the atmosphere and its radiative forcing. So when you talk about the greenhouse gases, the two important factors is there. One is the concentration of the greenhouse gas, the volume. The second one is the radiative forcing. What is the potential of that particular greenhouse gas to warm the atmosphere? That is global warming potential. The largest contribution comes from the burning of fossil fuels, mainly for transportation purpose or heating purpose, energy generation purpose, or even the cooling of buildings and industrial applications. There has been a remarkable increase in the combined radiative forcing of carbon dioxide, methane and nitrous oxide over the last few centuries, particularly since the Industrial Revolution. Their increase, these three important gases, during the past 4 decades has been at least 6 times faster than that observed over the last 2 millennia. These three important gases, carbon dioxide, methane, nitrous oxide, is very, very important. The human activities are estimated to have caused approximately 1 degree centigrade increase in the global warming in the last century. If you look at it, it's varying between 0.8 to 1.2 degrees centigrade. 1.1 degree centigrade is a very huge amount. So when you look at the greenhouse gases or changing atmospheric composition, we have to focus more on the carbon dioxide, methane and nitrous oxide. Let us see one by one. The first important greenhouse gas is the carbon dioxide. In fact, the measurement started in the year 1958 in Mauna Loa. It's a very pristine environment. Since 1958, we started measuring the carbon dioxide concentration in the atmosphere. However, we have seen in the last century, 19th century itself, we know the relation between the carbon dioxide and warming effect. Arrhenius has given the relation between the carbon dioxide and global warming. But only in the 1950s, we started measuring using instruments the atmospheric carbon dioxide concentration. And thereafter, we started analyzing the concentration, the trends of carbon dioxide in the atmosphere. And strangely, if you look at it, the concentration has been increased since Industrial Revolution. And then we were in a position to attribute the increase in the carbon dioxide to the human activities, particularly the economic activities, and also the population changes. Since the Industrial Revolution, the population has crossed, and now it is 8.2 and by 8.2 billion, and by 2050 we expect it to cross 10 billion. So huge population increase has been related to the use of energy resources or economic activities, and that has led to pumping of greenhouse gases, particularly the carbon dioxide, into the atmosphere. The present day concentration of carbon dioxide in the atmosphere is about 410 parts per million, And if you look at the per annum increase of carbon dioxide in the atmosphere is around 2 parts per million, 2 ppm. And when you look at the carbon cycle in the atmosphere, you'll be finding about 800 gigatons of carbon. And the vegetation, the biomass on the Earth's surface, the land biomass, it's around 610 gigatons of carbon. So the huge amount of carbon is stored in the ocean body. It's huge amount. So this ocean body is very significant as far as the carbon cycle is concerned, and for the mitigation of climate change is concerned, ocean system is very, very significant. So almost 39,000 gigatons of carbon dioxide is present in the ocean body in the form of carbonates and bicarbonates. So it's a huge storehouse. It's a sink of carbon. So this carbon present in the ocean body, it's somewhere related with the global carbon cycle and also the climate system. Since the ocean system is having a low inertia, thermal inertia, and also the thermo-island circulation, and the huge system, almost 70% of the Earth's surface is made of ocean body, and this is the reason why the Earth's climate has been regulated significantly by the ocean body. So the focus is that if the carbon dioxide concentration is increasing in the ocean system, what will happen to the pH value? What will happen to the organisms present in the ocean system? Because when the pH value is decreased because of the carbon dioxide content in the ocean system, perhaps in the last century, if you see, it has been decreased by 0.1 pH. But this reduced this pH value can have an impact on the living organisms, coral reefs, other organisms which is dependent on this carbon, ocean carbon. So this ocean system, how it is having an important role to play in the overall dynamics, climate dynamics that we have to see. So now let us see the main reason why there is an increase in the carbon dioxide in the atmosphere. The first important source is the fossil fuel combustion. The second important reason is the cement production, and the third important reason is the land use changes. We know fully well that along with the increase in the human population, the economic activities increased, and since industrial revolution we started to use more and more of fossil fuels for meeting our energy demands. Because of more use of fossil fuels, the carbon present in the fossil has been released into the atmosphere in the form of carbon dioxide. So this is a huge source, fossil fuel combustion. The second important activity is the cement production, and that is very much related with our, again the demand for the residents and demand for our own needs. So this is the second important reason. And as I told you, the third important reason for the increase in the carbon dioxide concentration in the atmosphere is the land use changes. You can see for ourselves to meet our demands, food demands, since industrial revolution, if you see, there is a lot of changes in the landscape, particularly more of deforestation has taken place, degradation has taken place, and that led to what? Definitely more of environmental pollution. And the deforestation is, the drivers for deforestation was agricultural expansion, urbanization, and definitely these two activities, agriculture expansion or urbanization, that has caused a lot of stress on the Earth's system, living system. When you look at the land use changes, particularly the agricultural activity, that is essential because we need to increase the food grain production to feed the growing population. But at the same time, it has also caused a lot of harm to the environment. And that has also released certain gases into the atmosphere. Let us see one by one later. These gases, particularly because of the agricultural activity, they have certain greenhouse gases, particularly the carbon dioxide, methane, and nitrous oxide has been released into the atmosphere. Now, the carbon dioxide as a greenhouse gas, it is called a greenhouse gas because it absorbs the long wave radiation at 2.7 micrometer, 4.3 micrometer, 15 micrometer. So now let us see the next greenhouse gas, methane. Very interesting greenhouse gas. The present day concentration is about 1800 parts per billion. during industrial revolution it was only 750 parts per billion. It's a huge amount. So from 750 parts per billion to 1800 parts per billion. The increase is definitely, because of human action that we can see for ourselves. Mainly the agricultural activity, the livestock rearing activity, the waste management practices. These are the reasons why the methane concentration in the atmosphere has increased. And if you look at it, the paddy cultivation, particularly the lowland cultivation, that is responsible for releasing methane into the atmosphere, because under waterlogged condition, the organic carbon present in the soil system, that has been converted to methane because it's an anaerobic condition. And this is a very important factor that has to be taken into account, particularly in the South Asian region, because in the South Asian region, paddy is widely grown because it's a staple food crop in the South Asia, whether it is Pakistan, India or Bangladesh. So rice production is a significant contributor for methane in the atmosphere. And this is an important factor that we need to take into account, because once we know the causes, we will be in a position to figure out the mitigation strategies as well. The second important source of methane in the atmosphere is the livestock rearing. When you talk about livestock, particularly because of the ruminants, because of the enteric fermentation, this methane is released into the atmosphere. And there are again a lot of causes, reasons why the enteric fermentation is responsible for methane generation, and that we can see for ourselves, because this can be because of the poorly fed feed and fodder to the livestock and the indigenous breeds, and also the natural system that is there within the rumen, the stomach of the livestock. The third important reason is the poor waste management practices, because the practices like anaerobic composting, or in other words not composting, improper waste management practices, that can also lead to pilferage of methane into the atmosphere. This methane is a greenhouse gas because it is absorbing the long wave radiation at 7.7 micrometer. But very interesting point as far as methane is concerned is that the short residence time. It's almost 9 to 15 years. It's a very short as compared to the carbon dioxide. That is the reason why these are called as short-lived climate agents or radiative gases. So their impact can be more dangerous in the shorter period of time. And this methane reacts with the hydroxyl group, and thereafter it will be dissipated, and that's the reason why it is having a very short residence time. Now this methane, when you look at the climate feedback mechanism, it is having a very positive feedback, because for instance, because of the increase in the surface temperature, the ice masses will melt, the permafrost region will be melting. When it melts, what happens? The methane lying below the permafrost region can enter into the atmosphere, then can leave the system, subterranean system, and can enter into the atmosphere. That is why it is having a positive feedback. So it is a very dangerous thing. The permafrost region, because deep inside the permafrost region, a lot of methane has been stored. So let us see next greenhouse gas. Next greenhouse gas is nitrous oxide. The concentration of nitrous oxide, the present day concentration is 320 parts per billion, and it has increased from 275 parts per billion. And the main source of nitrous oxide since industrial revolution is the agricultural activity, particularly the nitrification process is responsible for releasing nitrous oxide into the atmosphere. And what other sources? The forest clearing activity, even the fossil fuel combustion. These are the three important reasons why nitrous oxide concentration is increased in the atmosphere. And this nitrous oxide gets degraded in the stratosphere region through a process called photolysis. Nitrous oxide is again a greenhouse gas. It absorbs at 7.8 micrometer and 8.6 micrometer. So these are the gases responsible for causing climate change, and how human actions are involved in increasing greenhouse gases we have seen. Next important cause, anthropogenic causes, land use changes. Land use may be changed for various reasons, including but not limited for the urbanization activity, agriculture, industrialization. These changes, land use changes, bring about changes in the land cover. In fact, the most visible thing that we can see for ourselves is deforestation. So deforestation is having a negative effect on all the ecosystem services, and also the deforestation is responsible for releasing more of greenhouse gas into the atmosphere. If you look at it, when you remove the forest, the carbon dioxide sequestration potential has been removed. So that is a prime reason why deforestation has led to changing climatic condition. The land use changes impacts the precipitation pattern, soil pattern, and also land degradation. The deforestation, as we discussed, it can influence the climatic condition through changing the atmospheric composition, particularly the carbon dioxide, and also it can influence the hydrological cycle also. The anthropogenic land use change has increased the land surface albedo value, to an extent of minus 0.15 watts per meter square. Next one is the changes in the aerosol level. The atmospheric aerosol particles are very fine particles. They are suspended in the air. They are basically formed by the dispersal of materials at the Earth's surface or by the reaction of gases in the atmosphere. So either it can be a primary aerosol or a secondary aerosol. These aerosols include sulfates and nitrates from the oxidation process respectively during the burning of fossil fuels, because basically the sulfate and nitrate aerosols are released from the fossil fuel combustion activities. And sometimes the organic materials also are responsible for releasing the volatile organic compounds. The aerosols affect the climate through many ways. One is by increasing the scattering of solar radiation, interaction with atmospheric gases, and also indirectly also it can lead to the formation of CCN, that is called cloud condensation nuclei. So in that way also the cloud albedo is influenced. We have discussed the anthropogenic causes of climate change. At one small point is the climate feedback. How climate feedback is responsible for regulating the climate system, or in other words, how climate feedback is responsible for the present day climate. The average surface air temperature is 15 degrees centigrade, and this is all because of the lot of feedback mechanism that is inbuilt in the climate system. So the mean state of the atmosphere as well as its variations depends on the climate dynamics and interactions and feedbacks between the different components of the climate system. In fact, the climate feedback is an interaction in which perturbation in one climate quantity causes a change in another quantity, another way, and the change in the second quantity ultimately leads to an additional change in the first one. So it's a proper process, That's why it's called as climate feedback. A positive climate feedback is one in which the initial perturbation is enhanced. On the other hand, a negative feedback is one in which the initial perturbation is weakened by the changes it causes. So in the natural system, or a climate system, both feedbacks are taking place. Let us see one by one the different climate feedbacks. If you look at it, as I said earlier, that both the positive and the negative feedbacks occurs in the climate system. The internal processes are considered as those processes that occur within the climate system, and they include the atmospheric weather systems, ocean circulations, and also processes occurring at the interface between land and surface. The external processes are not affected by the state of the climate system. In fact, climate system is forced by the external processes. Let us see one by one the feedbacks. First and foremost feedback is the water vapor feedback. It's a significant positive feedback. and that in fact augments the sensitivity of surface temperatures to the carbon dioxide by nearly a factor of 2 when considered in isolation from other climate feedbacks. It's a very significant feedback system. In a warming climatic condition, the atmospheric carbon dioxide concentration, it will be very higher, but when you focus on the water vapor content, that also increases. Because of the warming climatic condition, the atmospheric concentration of water vapor increases, which greatly increases the greenhouse effect, and this will lead to further warming. This is called as positive feedback. While this positive or a water vapor feedback is reported to be largest in the tropics, where the tropical environment favors higher air temperature and maximum water vapor concentration. The polar regions experience weaker water vapor feedback because the concentration of water vapor is much lesser in the polar regions. The second feedback is the snow and ice albedo feedback. In a warm climatic condition, the snow and ice cover are expected to decrease due to increasing temperature. The melting of snow and ice exposes the underlying surface, which are either rock or oceans, resulting in more absorption of solar radiation. This positive feedback can amplify a cooling process as well as the warming process. Next one is the cloud feedback. This is a very important reason, a source of uncertainty in climate change predictions. Surface warming could result in the formation of more clouds, and consequently the increase in the albedo value on account of more clouds, because it could lower the surface air temperature. Since the original perturbation or surface warming is reduced in this feedback, the feedback is called as negative feedback. However, the clouds are formed of water vapor. Increase in the cloud formation due to surface warming could result in increased atmospheric water vapor content, leading to more surface warming. This is positive feedback because here water vapor is a greenhouse gas. It's a very interesting feedback, that's cloud feedback. Next one is lapse rate feedback. The lapse rate is defined as the rate of change of an atmospheric variable, usually the temperature, with height. That we have seen a lapse rate. What is the meaning of lapse rate? The stronger lapse rate leads to a stronger greenhouse effect. The lapse rate, the rate at which the changing any temperature or changes with the height, that lapse rate is influenced by the radiative processes and also convection and large scale dynamical processes. So in this session, we have discussed about the anthropogenic causes of climate change. The foremost important cause is the use of fossil fuels that has led to the changing the atmospheric composition of greenhouse gases. The second reason is the change in the land use practices. So these two are the most important activities, human activities responsible for causing climate change. Thank you very much.